Hello everyone, let us today discuss what is meant by electronic configuration and what are the different rules for writing the electronic configuration. So the distribution of electrons in different shells of an atom is known as electronic configuration. Now what you see in front of you are the different shells of an atom. In the center we have the nucleus. The first shell is numbered as 1 is known as the K shell. Second shell is named as the L shell. Third shell is named as the M shell and fourth shell is named as the N shell. Today we are going to study how we will arrange electrons in these different shells. So we are now going to study about the Bohr-Bury rules for writing the electronic configuration. The first rule states that the maximum possible number of electrons in a particular shell is given by the formula 2n square, where this n is small n and it stands for the serial number of the shell. Serial number means whether it is shell number 1, shell number 2, shell number 3 or shell number 4. So the maximum electrons which can be arranged in each of these shells is given by formula 2n square. If we put the value of n as 1 for the first shell, the maximum electrons come out to be 2. 2 into square of 1 gives us 2. For second shell, it is 2 into square of 2, that is 2 multiplied 4, maximum 8 electrons. Third shell, 2 into square of 3 gives us 2 multiplied 9, that is maximum 18 electrons. And for the fourth shell, n is equal to 4, so 2 into square of 4, that is 2 multiplied 16, that is 32 electrons. So this is the maximum number of electrons which can be put in these first 4 shells. Now coming to the second rule, it states that electrons are not accommodated in a given shell unless the inner shells are filled. That is, the shells are filled in a stepwise manner. Now to explain you this rule, let me give you an example. You all play lots of games on mobile and your computers. So whenever you play games, there are a set of levels that you need to cross. Unless and until you pass on the first level, you are not allowed to move on to the second and then third and fourth levels. Similarly, just like your games, electrons are also not allowed to move on to the second level or the second or the third or fourth shell unless and until they have completed the maximum number of electrons in their inner shells. So let's take the example of lithium here. It is the third element in the periodic table, has atomic number of 3. Now whenever we write the electronic configuration, it is written on the basis of its atomic number, because atomic number provides us the number of protons and electrons for a neutral atom. So maximum electrons which can come in the K shell will be 2. And now since lithium has total of 3 electrons, we are left with 1 more electron. That 1 electron is going to move on to the L shell. So there will be 2 electrons in the K shell and 1 electron in the L shell. The total comes out to be 3. So total electrons in lithium are 3. This is going to be the correct electronic configuration. However, we cannot write its configuration as 1 electron in the K shell and 2 electrons in the L shell, because here also the total comes out to be 3. But this will be wrong, since this shows that the first level or the first shell is not complete, but the electrons straight away jumped on to the second level or the second shell. So this is just not a possible case. So this is going to be the wrong electronic configuration for lithium. Let us try to understand this further by taking the example of neon. Its atomic number is 10, so protons, electrons are 10. So there are total of 10 electrons. So maximum 2 electrons can be filled in the K shell. So 2 electrons in the K shell and then maximum 8 electrons in the L shell. 2 plus 8, the total comes out to be 10. So that's correct electronic configuration and it is also following the rule. Now if we write 0 electrons in the K shell, 8 electrons in the L shell and 2 electrons in the M shell, it is going to be the wrong electronic configuration. Now the reason for it is, since this means that the electron did not pass the first level, did not move on, did not fill in the first shell, straight away moved on to the second shell and then the third shell. So it is going to be a wrong way of writing the configuration. Let's take example of magnesium. Its atomic number is 12. So its configuration is going to be 2 electrons in the K shell, that is maximum 2. Maximum 8 electrons in the L shell and we are left with 2 more electrons which will move on to the M shell. So 2 plus 8 plus 2, the total comes out to be 12, is going to be the correct configuration. However, if we write 2 electrons in the K shell, 7 in the L shell and 3 in the M shell, here again what we are getting is that it filled 2 electrons in the K shell, it could not fill the maximum electrons in the L shell, and the remaining electrons straight away moved on to the M shell. It is again going to be a wrong electronic configuration. So this was about the second rule. Let us now move on to the third rule for electronic configuration, which is basically applicable for elements potassium and calcium. The outermost shell of an atom cannot accommodate more than 8 electrons even if it has the capacity to accommodate more electrons. Let's take the case of calcium. Its atomic number is 20. So we cannot write its configuration as 2 electrons in the K shell, 8 electrons in the L shell and 10 electrons in the M shell. This is where this rule is applicable. It says that outermost shell cannot have more than 8 electrons. So we cannot have 9 electrons here, we cannot have 10 electrons here. So its correct configuration is going to be 2 in the K shell, 8 in the L shell, 8 in the M shell and 2 in the N shell. And this is because it needs to follow the rule of stability, which says that it should have 8 electrons in the outermost shell. About stability, I will discuss it in another video, and the configuration of first 2 elements will also be discussed in the next video. I hope children you all have understood today's topic. Thank you.